Hi, this is Professor LaShan, and I'm going to go over the examples in section 2-2 from our Math 107 course. So I'm going to start first with example 2-4 on page 57. And to do that, we're going to go back to the record high temperatures example from example 2-2 on page 47 from the earlier video, where we constructed a group frequency distribution with class limits, class boundaries, tally, and frequency. And we're going to use that now to make some graphs. So the first graph we're going to talk about in example 2-4 is a histogram. And in a histogram, it's a bar graph, and the bars are touching, they're vertical bars, and we are going to use the class boundaries and the frequency columns. Class boundaries along X, frequency along the Y-axis in order to make a histogram. So we're going to use this information that we have back from example 2-2 on page 47 to make our histogram, and it's showing it also on page 58 if you're following along. So let me just move this up, and in order to draw our histogram here, we're going to have X and Y. X is here, Y is here, and along the X-axis we're going to put our class boundaries from our graph here, this column here of class boundaries. So we're not starting at 0, so I'm going to make a break, and we're going to start with 99.5. Remember, we were adding 5, so 104.5, 109.5, 114.5, 119.5, 124.5, 129.5, and extending this a little bit, 134.5 are the class boundaries. And these were record high temperatures, so you always want to label your axes. So I'll call that temperatures. Whoops, I'm going to move this up so you can see it. And then along the y-axis, we want to put frequency. And the highest frequency that we had here was 18. So we need to go on the y-axis up to 18 for frequency. You can count by 5s, you can count by 2s, you can count by 1s, whatever works for you. Since I don't have a lot of room here, I'm going to just count by 5s. And I should also say here that, of course, all of this is obviously better with graph paper. To do this with graph paper, it's more accurate. And so we want to label that this is frequency. All right, so from 99.5 to 104.5, this first class has a frequency of 2. So from 99.5 to 104.5, we're going to draw a bar to a height of 2. The next class from 104.5 to 109.5 has a frequency of 8, and the bars are touching. So from 104.5 to 109.5, we draw a bar to the height of 8. Again, always better with graph paper. The third class from 109.5 to 114.5 had a frequency of 18. So we're going to draw to a height of 18 approximately for that bar. The next class, which goes from 114 to 119.5, has a frequency of 13, so that's the height of that bar. Bars again are touching. Notice the class boundaries are on the boundaries of the bars on the edges. And then the next class, which goes from 119.5 to 124.5, had a frequency of 7. The next class from 119 to 100, yes. The next class from 124.5 to 129.5 had a frequency of 1. And the last class from 129.5 to 134.5 had a frequency of 1. And so there is our histogram that shows the data for the record high temperatures coming from example 2, page 47. And as you can notice, as you can see from looking at the graph, there weren't that many data values on the low and the high end for the record high temperatures. The most of the data was there in the middle, and the most likely thing to happen was that the record high temperature fell between 109.5 and 114.5. So that is a frequency histogram. So the next example that we're going to do is from, and again, that was example 2-4 from page 59. So the next example, sorry, page 57. Let me get the page right there. So the next example we're going to look at is example 2.5, also with the record high temperatures, which is on page 58. And this one we're making what's called a frequency polygon. That's a line graph where the lines are continuous. And when we're making that graph for a frequency polygon, along the x-axis we're going to use what's called midpoints. And so we actually don't have midpoints yet in our graph. So let me pull back that example 2.2 so we can get midpoints in our graph. So here's our original data, and I need to come down to the next level here to find the midpoint. So midpoints are the points that are halfway in the middle, in between each of these, in each of these classes. So you can either add the class limits together and divide by 2, or add the class boundaries and divide by 2. So if I want the first midpoint, I'll put the calculation over here. I'm going to do 100 plus 104, add first, which gives you 204, divided by 2, which gives us 102 as our first midpoint for our first class. For the second class, I can keep doing that. I'm going to add the class limits, 105 plus 109, which gives me a 214. And we're going to divide by 2, which gives me 107 for the next midpoint for the next class, and so on. If you recall back from the example 2.2 on page 47, we had a class with a 5, what I called the magic number. Once you start finding some of these numbers, you can just now add the class with the 5 to get the rest of them. So we can keep with this process of adding the class limits and dividing by 2, or we can just say, okay, I know the first midpoint, and then we could add 5 to get the next one. We can just keep adding 5. So for the third class, the midpoint, sorry, let me put it in the right spot here, because actually the first midpoint goes here, 102, and the next one is 107, adding 5. The next one is 112. The next midpoint adding 5 is 117. Adding 5 is 122. Adding 5, 127. And finally, the last midpoint adding 5 is 132. So this spot here doesn't have anything because this is, we're going to go back to the cumulative frequency. So the classes actually line up the 7 classes starting here. And if I had more room, I'd put that all in one spot here. So we're going to take this information about midpoints along the x-axis, and along the y-axis we're going to do frequency, and we're going to go to example 2.5, which is on page 58. And again, x is midpoint, and we remember our first midpoint, since we're not starting at 0, I'll put a break here. So the first midpoint was 102, and I'm just going to list them: 107, 112, 117, 122, 127, 132. Okay. And again, we want to label what's what, and these midpoints were temperatures, record high temperatures. Along the y-axis, we're doing frequency, and again, as we saw from the earlier graph, the highest frequency was 18. So I'm going to count by 5s as I did before. Again, as I said before, everything is more accurate when done with graph paper. So we're going to put above each midpoint, we're going to put a dot for a line graph to the height of the frequency. So the first class had a midpoint of 102, its frequency is 2. So I go to a height of 2 over 102. The second class had a frequency of 8 with a midpoint of 107, so that's where I put the dot. The third class had a midpoint of 112, its frequency is 18, so that's the height of that dot. The fourth class had a midpoint of 117, and its frequency is 13, so that's the height of that dot. The next class had a midpoint of 122, its frequency was 7. Just 8 a little bit higher, and 7 is the height of that one. The next class had a midpoint of 127, its frequency was 1, and the last class with a midpoint of 132 had a frequency of 1. So we connect the dots with straight line segments to make what's called a frequency polygon. And something important to do is you just bring those lines back down to the x-axis to close off the graph. And that's what they do on the graph there. They'll even put a dot here. It's not really super important, but you can put a dot here when you bring it back down to the x-axis. So that's called a frequency polygon. And the last kind of graph that we're going to talk about here, and then we'll do a variation on that, is called an ogive. The ogive graph is for example 2.6, which is on page 59. And it's called an ogive, and that's a line graph, but along the x-axis we're going to use cumulative frequencies. Along the x-axis we're going to use class boundaries, is what I meant to say, and along the y-axis we're going to use cumulative frequencies. So when we go back to our original data, we have class boundaries here starting at 99.5. We're just going to list them all the way up to 134.5, not repeating them because they overlap. So we're going to start, and I made a break there since I'm not starting at 0. 99.5, again, just listing class boundaries, 104.5, 109.5, 114.5, adding 5, right? Yes. 5, 14, yes. And then 119.5, 124.5, 129.5, 134.5. And those were the class boundaries, and what they were record high temperatures, so we want to put a label. And then along the y-axis, we're using cumulative frequency, and cumulative frequency goes up to 50 here, goes up to 50. So I'm going to count by tens because I need to count up to 50, and I don't have a lot of space here. Again, use graph paper, make it more accurate, but we need to go up to 50 because that's the cumulative frequency that we get to. Always important to label. So the most important thing about an ogive is the correct starting point. And what you want to do is you want to put the cumulative frequency of each class at its upper class boundary. So at 99.5 here, the cumulative frequency, what is below that, that's our start point, is 0. So that's what we have that line in the graph. At 99.5, we have no data. Remember, the lowest value was 100. At 104.5, the cumulative frequency, all the values that were below that, is 2. So that's the height of that bar. At 109.5, below 109.5, the cumulative frequency is 10. So at 109.5, I put a dot at a height of 10. At 114.5, the amount of data that falls below that is 28. And where we're getting these numbers from is we're taking the frequencies and we're just adding, keeping a running total. So at below 114.5, you have 28 values. So at 114.5, you go to a height of 28 and put a dot. Below 119.5, you've accumulated 41 values here, 41 here. So at 119.5, you go to a height of 41 and put a dot. Below 124.5, you've accumulated 48 data values. So we go up to a height of 48 over 124.5. Below 129.5, we've got a cumulative amount of data of 49 values. So 129.5, we put a height of 49. And finally, at 134.5, we've accumulated all the data, all 50 values. Remember, the highest data value in this data set was 134. So at 134.5, we've reached 50 cumulative data values. And you connect these with straight line segments. The more vertical the line segment, the more straight up and down the line segment, like this class here, means the more data there was. And that was our class that had the most data of 18 values. This one's fairly vertical, that had 13 values. And so again, always more accurate with graph paper. And I'll continue for the rest of these examples on the next video for this section 2-2 example.